Like for the first problem, anytime we are solving an equation, we can always put one side in for y1 and one side in for y2 and see where they meet. It looks like they don't quite meet, but when you go to the table feature and you plug in the most likely answer, 0.5, in for both y1 and y2, you see that both y values are 0. So that's one way to find the solution using the calculator. It's also pretty obvious from the graph that they don't meet anywhere else except for this one spot right there. Now we'll do the algebraic approach. We would need to square both sides in order to undo the square root, and we'd have 3 minus 6x on the left. On the right, we need to remember that we actually are boiling this out or doing a box multiplication to get the right answer. When we do the box multiplication method, we get 4x squared minus 4x plus 1. We would add 6x to both sides, and we would subtract 3, so that we have our quadratic equal to 0. Now we have 4x squared plus 6 on top of minus 4 would be minus 2x minus 2. Next, I would factor out the common 2 and have 2x squared minus x minus 1. Now I would go back to a box method to try to factor this. We know our first term has to be 2x squared. That's only going to come from a 2x and an x. And our final term has to be negative 1. So that's only going to come from 1 and 1. We had negative x in the middle, so that must mean we have a negative 1 here for negative 2x, positive 1 there for positive x. Now when we combine all our like terms, 2x squared minus x minus 1. That means our solutions are x minus 1 and 2x plus 1. In looking at my answer, I can see I've made a little error. When I combine negative 4x and 6x, I would have a positive 2x, meaning I have to have a positive 2x here and a negative there. So my factors are x plus 1, 2x minus 1, and my zeros are negative 1 and positive half. And that, of course, shows up as answer A. However, I should always check and see, and it turns out that this is an extraneous solution when I try to plug it back in. 2 times negative 1 minus 1 squared will not equal the square root of 3 minus 6 times negative 1. As proof, 1 does not equal 3, so 1/2 is our only answer. But remember how much faster the graphing calculator approach was than the algebra approach. Make sure to look to see where calculators are allowed.